Hi guys, so here we are with the guided examples and take a look at this table for a moment. We have students in elementary school and students in middle school and whether or not they go to bed before 9 p.m. Uh, so I want you to think if there is a relationship between those two categories. So do you think that their bedtime has anything to do with the grade they are in school? Why or why not? Pause this video if you need to, and then let's move forward. I'm gonna show you the full table. Okay, hope you pause that to think about this question. And here we have the full table. So we have 16 students and out of 20 in elementary school that go to bed before 9 p.m. and 4 that go to bed after 9 p.m. and 2 students in middle school that go to bed before 9 p.m., 18 after 9 p.m. So now, do you think there is a correlation between those two categories? Why or why not? Take a moment to analyze this table. Okay, so now we are going to see how we can mathematically analyze it and answer this question. You might have an opinion about it. Now it's time for us to prove it wrong or right. So let's start with the meaning of association. So association is a connection between people or things. And an association will exist between two categories in a table like that if there's a difference in their conditional probability. So we can have two types of things. Our variables can be associated or independent. If you think there is association between the bedtime and the grade in school, they are associated variables, and if not, they will be independent variables. So, and they will be independent variables if there is no difference in their probability or if the difference is small. So we're going to go back to that table and analyze the data and see if we have an association or not between the bedtime and the grade that the student is in school. So this is our table. So if you think that there is an association between the bedtime and the grade in school, you are correct. But how can we prove that? So we're going to calculate two probabilities from the table and make a conclusion about it. So that's our goal. So let's take a look at the percentage of students who go to bed before 9 p.m. given that they are in elementary school. So remember about our data and about the words in our problem. Every time that we say given, that means that will be our total, our denominator. So given they are in an elementary school means that our denominator is 20, the total number of people in elementary school. So we want the percentage of students who go to bed before 9 p.m. So we have 16 out of 20. And in this situation here, it's very important for us to put in percentage because it will be easier for us to compare. So 16 divided by 20, we have 0.8. And if we move 2 decimal places to the right, we will find our percentage. So we have 80%. And then we need to take a look at the percentage of students who go to bed before 9 p.m. So the same variable, but given that they are in middle school. So given they are in middle school, so the total number of people in middle school is also 20. So our denominator is 20. And then students who go to bed before 9 p.m. 2. So 2 out of 20, we have 0.1, and that will be 10%. So as we saw above about the definition of association, so if there's an association, that means that we have a difference in the conditional probability, right? And if we compare both percentage, there is a difference. One is 80% and the other is 10%. So it's a significant difference. So what conclusion can we make about this table? So our table will tell us that since there's this big difference between the conditional probabilities, there is an association between bedtime and the grade in school. So the students in elementary school are more likely to go to bed before 9 p.m., right? They are little kids and they need to sleep early. So in our data, our percentage will show us that. Does that make sense to you? If not, please pause the video and watch it again. And we can also talk more in another example. This next example is data. We have a data about the fact that you are right or left-handed and the city that you live in. So the states of Colorado and Texas, they want to conduct a study and see if there's any relationship between the city a person lives in and whether they are right or left-handed. So we have some results here. Out of 65 people surveyed in Denver, Colorado, 58 are right-handed and 7 are left-handed. Out of 35 surveyed in Dallas, Texas, 31 are right-handed and 4 are left-handed. So we saw that in past classes this week. Let's create a table that will model this data. So I'm going to scroll down and I want you to take a look at our table. So remember at the first cell, we don't write anything in there. And you have right-handed, left-handed, and if you are from Denver or from Dallas, and the information on a table. Remember that you need to write down the total as well. And that's our table. So after creating this table, let's see the probability. Let's analyze our conditional probability here. So 2 questions. What is the probability that a person surveyed is right-handed given that they live in Denver? So given that they live in Denver. So this is our denominator. So all the people from Denver, we have here 65. So our denominator is 65. So what's the probability that a person is right-handed? So here from Denver, so we have 58 people out of 65. That's our fraction. And again, write down as a percentage so it will be easy for us to compare. So you have 89.23% of the people in Denver. And then another question is, what is the probability that a person surveyed is right-handed given that they live in Dallas? So given that again, pay attention to that word. So people who live in Dallas, they are our denominator. So we have now 35 as our denominator and the probability that the person is right-handed, 31. So 31 out of 35, that's our fraction. And divide and write down as a percentage. So we have 88.57%. So you can see that those two percentage, those two results, they are very similar. So what does that mean? Do you remember about our definitions? Let me go up. So if there is no difference or the difference is small, that's our case, the variables are said to be independent. So now in this example, there is no correlation between the variables because the difference between them is super small. So being right or left-handed has nothing to do with the city that you live. So since the data is basically equal, there is no correlation between the fact that you are left or right-handed and the city that you live in. Does that make sense? I hope so. So thank you guys. Now you're ready to go to the practice. Do one problem by yourself and then take your mastery check in this one note. Thank you.